Welcome to a new test and teardown video. Look at the leather. The quality is just absolutely amazing. The state this is in, it looks like brand new. So Gossen, that is made in Germany. So it looks like this instrument is kind of locked in here, right? And this is a Lux Meter, so it's measuring light intensity. And the meter itself is, upside down, in a very good shape. I see some metal parts down there that's like not where they're supposed to be. And this is also preventing the needle from moving. So I need to open it and see if I can fix this. Also, I see this is not moving. This is just loose. And then there's a little hole here where you can see nothing. And here you go. 2 banana plugs for the meter. And here's the battery compartment. When I see a battery compartment, I always go a little bit, ooh, is there a hidden battery in here? And also looks like nobody was in here. But look what I found here. 6 month 71. So this is 51 years old this year. And if you look a little bit on this meter, it looks exactly like the KTAS ohm meter I released a video about a long time ago. I will put a link to that in the description, so please check it out. And you will see that it is exactly the same casing and exactly the same backlight, because this is exactly what it is. So yeah, I better open this and see if I can repair this. Oh yeah. So this is the sensor, and what you do here is just twist and then remove. So this is like a light attenuator, and it says a factor of 20. So this one takes away the light, and they kind of milled down here for thickness, so it's calibrated or adjusted to the exact thickness. Isn't that just amazing? So this is how to make it read 20 times more lux, and then you just multiply the value. As far as I can see, we got 3 different scales in here. So I guess this is the scaling. There's probably supposed to be a switch or something in here, but that is completely broken. And also, if you see the leather case, you should be able to access this via the case. So I believe this is important. I think this is like a photovoltaic element. So that means you just give this light and out comes a lot of voltage. I will check this out in a second. So yeah, now I've connected it to my voltmeter. So this is definitely like a solar cell. So it's a photovoltaic detector. So this is the light level I got here. Let me take this all the way up to my lamp. And then we got 230. And what happens if I put on the attenuator? So that was is it 20 times less? Let's put it all the way up to the lamp. I don't know. I think it depends on the meter, right? So we need to load this with that meter to get 20 times less reading under the same conditions, right? But so far I think this meter is really, really beautiful. In a super good state. It's very heavy. Let me see if I can get this opened. I think we are very lucky. There's no battery in here. It's not supposed to be a battery, but they just left this battery compartment here because this is of course the same case as they used in the ohm meter. So far so good. So now what is the trick with that one? To figure that out, I think I need to open it. Oh yes, that was easy. Only 4 screws from the back. Oh, we got some fancy coils and stuff down there. And yes, there was indeed some sort of a scale here. So what is the trick? Ooh, what the... Oh, so that one goes in that one. Ooh, and it's completely broken. So there's supposed to be something. This is 1 screw only. Oh, we got 2 screws down there. And there's another little metal part. We also got the 2 metal parts here. I guess, oh, they're magnetic. Oh no. It's getting more and more mysterious. The more I shake around with this and try and poke around here, the more little parts fell out. So now I got all those parts to puzzle. And those are a little springy. So they're probably in here somehow. I've got those 2 screws, they look like they fit in here, right? But there's just no way. So this whole thing was rotated. But how is that possible? Because all the wires, they fit so nicely this way, where it kind of is. So how is that possible? So look at that. So there's definitely a switch. Here's what I did. I removed the little cover for the screw, and then I could remove the knob. And now I'm going to take all this off and see if I can rebuild the switch, because I think I've figured out how this switch works. This is the rotating contact, and this is the one that is rotating here and making a contact between these 2 and those 2 and those 2, like that, right? So this one is supposed to go like this in that one, and then got the springies. But I didn't figure out yet about the little round one as well, where that one go. Maybe that fits in here. And there's also a little springy. We need to be very careful not to touch in here. That was very difficult to assemble, but look at that. I think I made it. What the heck? If this turns around and say like click, click, and there's a connection and whatnot, I mean, I would be really, really impressed if that is the case, but I think I kind of did it, didn't I? Didn't I forget anything? And see, the little contact thing is actually in there. Whew. Alright, let's try and see if it works. Now I know what this thing is doing. This is actually different load resistance. The voltage here is the same. So this is about 50 millivolts, and when I turn this, the meter here is exactly the same, because I'm now using a DC power supply. but I can now see about 3 milliamps. See, 3 milliamps at 53 millivolts. But if I turn the dial down, I don't see the current, but I get the same readout in voltage mode. So what this is actually doing, it's measuring current from this. So it's a current source, not a voltage source. And this is the different load resistor that makes this into an amp meter, right? What is that? Serial number or something? So that will be the two different load resistors, and they just go in parallel with the meter. And this is also what we see here. See, there's a wire from the input, and over here is also a wire from the input directly to the meter. And then we got two other wires going to the variable shunt resistor. So over the 50 years, the current capability of this probe is more or less gone. See if I give it a flashlight here in the most sensitive mode, I see almost nothing. Let's see if I can give some more light and see what happens. But I mean, this is indeed a powerful flashlight, so now I'm going to try my most powerful flashlight. So I'm going to start with the ×20 magnifier here, or attenuator, okay? Oi, oi, oi. I should need to be careful not to melt this, because that is like a crazy thing. So I mean, oi, oi, oi. This is not good. So let's measure the open circuit voltage, and it's only about 200 millivolts, and this is a flashlight directly into the sensor, so I mean it's totally dead. And let's see what kind of current it can do, right? Yeah, we just needed a more sensitive amp meter, so this is the dark level, and now I removed my hand, so we got some microamps, and now I put the flashlight up its face, so we got like 7 microamps. So there's no more power left in this sensor. But what I could do is I could probably take this apart and put in a new, like a solar panel from eBay or something like that, and kind of fix this whole thing. Yeah, we got some screws here, so it's possible to open this and put in a new solar panel. This is the inside of the probe. So the wire just go up here. Oh yeah, look, there's a tiny little black wire that goes on the front, and then the other one goes to the back. And then there's a spring to kind of hold it. See if I push it from the other side, so it goes up. We also got the date. I think it says 7351. So yeah, this meter is from 71. Exactly as I imagined. I think I will measure the diameter here and see if I can find another sensor on eBay or something, because I think this is a super cute instrument. So I think this is where we're gonna stop this video, and then I will go shopping, see if I can fix this. And now I will assemble all this. It's pretty easy. I'm super proud that I was able to assemble and fix this switch. So thank you for watching. Come again soon.